Ready? Okay. All right, so now we've gotten past our technical difficulties. So element 3 then, this first shell or this first level or this first orbit can only hold 2 electrons. But lithium needs to have 3 total. It needs to have 3 total so that the positive protons and the negative electrons can balance each other. So here we have element 3, lithium. Here's element 4, beryllium. It would have 4 protons in its nucleus in the middle. It would have 2 electrons on the first level, and it would need to have 2 electrons on the second level because it's got to have 4 electrons total to balance out the 4 protons in the nucleus. All right, then element 5, boron, but there's nothing boring about boron. It's not boron, it is boron, not boring, so it's fine. I'm sure it's never heard that joke before. All right, so 5 protons in the nucleus in the middle, put that there, and it's going to have 2 electrons in the first shell, and it's going to need to have 3 electrons in that second shell. Now the second shell is bigger, so it's got more area, it can hold more electrons. So just like if we had a marble and a baseball and a softball and a volleyball and a big old beach ball, as the spheres, as the balls got bigger, there'd be more area on those balls. All right, so here's element 5. Oops, I forgot to put down Be for beryllium, B for boron. And if we kept going, we could just keep going with this little pattern. If we got all the way to the end of the row, so these little dots here are going to show that I'm skipping. If we got all the way to the end of the row, let's do number 10. Let's do neon. So as element number 10, neon is going to have 10 protons in its nucleus, and it's going to have 2 electrons on the first orbital, and it'll have 8 electrons on the second orbital, so that the positive protons and the negative electrons balance each other out. And here we've got neon. Okay, however, if we were going to do sodium, element number 11. So if we were going to do element number 11, sodium, being element number 11, is going to have 11 protons in its nucleus, and there'll be 2 electrons in the first orbital. There'll be 8 electrons in the next orbital, and that next orbital is now full. So there would need to be yet another orbital. And so as we keep building bigger and bigger and bigger atoms, well, they're getting bigger. So, but you've got 11 total negative electrons in the orbitals, in the shells, or the electron cloud, depending on what model you like to describe your atom. But you've got 11 negatives on the outside to balance out the 11 positives in the nucleus. And again, there is another component to the nucleus. There's the neutrons. We will talk about them some other day. Right now, we are looking at the basic pattern of the table so that we can quickly pull off information. And here we've got the next pattern, because this gets into what the rows mean. So every time you go down a row on the periodic table, you end up adding another electron shell or orbital or level in the electron cloud, however you like to say it. So element number 11 was sodium. One more of these. Element 19, potassium. So we'll have to skip. Element 19, potassium. 19 protons in the middle, 2 electrons on one shell, 8 on another shell, 8 on another shell, 1 on another shell, for a total of 19 negative electrons to balance out those 19 positive protons. But we added a whole nother shell for potassium. So if we head back over to the table, every time you go down a row, if you drew that atom, there would be another electron shell added to the outside. So hydrogen and helium are on the very first row. They've got 1 electron shell. Lithium through neon, they are on the second row. If you drew them out, they would have 2 shells. Sodium and on over to argon, if you drew them out, they would have 3 shells. Potassium on over to krypton, if you drew it out, they would have 4 shells. Rubidium all the way over to xenon, if you drew that out, that would have 5 shells. So right now you can tell on the periodic table how many protons an atom has, and if it's going to be an atom, it has to have, if it's going to be an electrically neutral balanced atom, we'll get into what happens, when electrons start moving around in a couple days. But for now, if it's going to be an electrically neutral balanced atom, then it would also have to have that many electrons. So if we had a chromium atom that had